going to talk about generative AI applications with Google Cloud databases and Cloud Runtimes. So I want to keep it as engaging as I can, in the sense I want you to ask questions, or rather answer in the first place, and then eventually as I get towards the end, you probably can ask questions if we still have time. So my name, as I was already introduced, so you all know that, and if you'd like to connect, here is my LinkedIn. All right. So, do you know that, like everything else, this also dates back to, I mean, even databases date back to, monkeys and things with Ishango bone. I don't know if I'm saying it right. Is it Ishango bone or Ishango bone? I don't know what it is, but it dates back to the time where we don't even know which animal the bone belonged to. But that's back when we, at least what we know of at the moment, is that that's the first few traces of how databases and mathematics, like probability, any kind of data math was used to solve some real world problems, to solve some some business problems, mathematics and everything. Those days, it's at least 50,000 years ago, according to some documentation. I have no proof for this whatsoever, but there is some proof available. So yeah, the whole point is we evolved from over there. So it's been there all around. Maybe the term data or database was not coined back then, but then eventually it is inevitable. Like we talk about so much. We talk about LLMs all the time. We talk about models. We talk about doing so much with multimodal data, which is data of all formats and types, structure, volume, veracity, so on and so forth. But databases is one thing that's irreplaceable, like something that you would continue to need, would continue to require, no matter how farther along we go in the world of LLMs, right? So we started off like, we didn't start off like this, of course, because we were, we were talking about bones here, but then somewhere in the middle, we fell back to something like this, where applications spoke to databases, as simple as that. How many of you are in the database world? Like, I like to write SQLs, I like to do analytics, analysis, and so on and so. If everything can be done in databases, how many of you have worked with OCI and stuff like that with Oracle, like back in the day when everything could be done? Yeah. So it's so much fun. Like I have done that too. It's like I used to be the kind of person who says that's everything. Like you don't need anything else. Like you can just build your application, you can build your front end, you can do whatever you want back then when user experience was subjective. So yeah, so that's the kind of person I was. But still, the whole point is, even now, I know just as much as I believe. So there are so many other people out there who want, including business analysts, including folks from data engineering, data science teams, most importantly, the business teams, which actually think about what is next, how can we improve business, what can we do to bring in the results that we target to, whether it's a startup or an enterprise or an organization, or it's an individual programmer, it's an individual application, anything of that sort. Whoever is thinking about what is the ROI, what is the result for this, will always think about bringing it all in a place where it's resource efficient, but at the same time, it is accessible, right? The proximity to everything that's brand new, everything that's amazing is very close to the data where it lives. So I'm one of those people too, who like to do a lot of things within the scope of databases itself. So that's what we're going to look at today. And generative AI, of course, here I'm going to stop, pause and ask a question, because we have been talking about generative AI and models quite a bit. I think a lot of sessions also, I see the topics and everything covered a lot about Gen AI. So I want to pause here a little bit and ask some of you to just put your hand up, and if possible, just speak up from there. I think I can still hear you from here. What is the difference in your mind, between machine learning, artificial intelligence, and generative AI? Like, it doesn't have to be deep tech. It can just be as simple as it is in your mind. Just keep it simple. Come again, please. Machine learning is a what? Okay.
Produce data from learned behavior, learned attributes, and AI is all-encompassing term.
Okay. Anyone from this area wants to try? So that's what you believe. Okay. Okay. Hold that thought. Anyone else from this side? Okay. Anyone here? One last time I'm going to ask this, and then I'll probably get to what I think it is. Anyone from the side?
AI is a subdomain of deep learning where we basically focuses on generating something. Maybe it is a text, maybe it is an image or anything.
Okay. Cool. So collectively, there is no wrong answer here, but yeah, I would talk about whether ML is part of AI or that sort. Some one answer that I got here was probably a little bit hierarchically, I would say, misaligned. But that's not about the hierarchy I was talking about. If you leave the hierarchy aside and the technique or the terminology aside, what I would think is machine learning is where you would bring the data, right? In some cases, in supervised learning or scenarios like that, you would bring the data, you would teach the machine to do something, get the machine to do something, right? So that those were the days when we got the machine to do something for us, like a natural language problem, or identify what kind of an image it is, or extract something from a big essay or a context, or so on and so forth. There are so many use cases. Artificial intelligence is very similar. I mean, yeah, of course, hierarchy-wise, it's like the broader broader concept under which everything else falls. Yes, but having said that, what I personally think is that it still has got a lot to do with data that's more interactive, that's more in the real world, like sensor data, data of vision, data from cameras, data from videos, live streams, so on and so forth. Like anything that interacts that or has a physical connection in the real world with us is what I would think is an ultimate, like an AI solution. Not that the other traditional like machine learning or applications that live maybe not physically, maybe not along with us in the real world, but live within a box, doesn't mean that it's not AI. But you know what I mean, like sensor data or data that's differentiated or data that interacts with you in the real world is what I'm talking about as AI. And with generative AI, we went one step further ahead, where we are not asking the machine or teaching the machine to do something. Rather, we are asking them, we are not teaching it, we are not providing the data. I mean, not necessarily providing the data, but we are rather asking the machine to do something for us, right? Like instead of training, instead of giving it a bunch of data and saying, this is what prediction is, this is what forecast is, and this is how you do it, we have gone from there further ahead to a spot where now we are asking it to just, can you generate this? Can you generate a story? You have to keep into account all these components. Of course, you can augment it with data. You can provide more data as context. You can provide fine-tuning. You can provision distillation. You can do so much with the data. You can ground it. You can provide context, so on and so forth. You can still give it data. You can still make the machine work in a way that you expect it to, the generative AI models. But still, it is a point. It's clearly, there is a clear distinction between where we started as machine learning to where we are right now with generative AI, where we just ask the machine to do something, right? So that's one thing I wanted to get out of the way, because there's always this questions asked about, okay, what is this? Now we spoke about generative AI. What is Vertex AI? What is Gemini? So generative AI, like I said, is the overarching concept where we are talking about asking the machine to generate something. Now, what is Vertex AI in the context of Google Cloud? We have Vertex AI, which is a one-stop shop or a suite for all ML, AI, and generative AI needs. It has your models, foundational models, open source models, models where, or even the models that you write and host, you want to host it. It has Model Garden. It has models that are segmented by tasks, that are segmented by the modality, which is models that are suitable for audio, models that are suitable for images, videos, so on and so forth. And it has everything that you need to devise your end-to-end machine learning operations pipeline, or for that matter, generative AI ops pipeline, or general AI ops pipeline, right? So everything that you need with respect to building this entire architecture, not just from an LLM perspective, not just from an ML perspective, but overall, everything that you need for ML, AI, generative AI, and the operations, observability, monitoring, endpoint, APIs, so on, and anything that you want to do with it, it's available within Vertex AI. So that's what it is. It is one of the services or products in Google Cloud. The reason I'm getting that off the way right now is because when we get to the point where I'm talking about specific database, I'd use Vertex AI a lot. It confuses a lot of people when we talk about Gen AI, Vertex AI, and Gemini. So I wanted to clearly distinguish between the two. It's a concept when we talk about generative AI. Vertex AI is a product that encompasses all of these things. And then we have Gemini, which is a model. Of course, we'll be talking about vector search and embeddings today with AlloyDB. We won't be specifically using Gemini, the model, in order to make generative AI insights. The reason is that's fairly, how many of you have tried Gemini here from Vertex AI? Yeah, quite a few, quite a lot actually. Okay, so I will not be asking you to just use this model and then try to ask Gemini to create something for you. Rather, I would be telling you how we'll use embeddings and do vector search from within the scope of database, and then deploy that into a web application that's on a REST endpoint on the cloud. Right, so that's something what we look at today. So I wanted to clearly distinguish between these terminologies that we'll come across. So these are some stats here, and why it's important for us mainly to bring in data, or bring in generative AI to data right where the data resides, right? So how many of you have actually used LLM model creation, model insight generation from within the scope of database, any database, without having to write Python code? Do you know it can be done? No? Perfect. Yeah, BigQuery can do it. All of Google Cloud databases, well, most of it, like Cloud SQL, AlloyDB, which we'll be looking at today, BigQuery, Spanner, all of these databases support generative AI from within the scope of database itself, which means the proximity to data, which is what we are looking at right here. Proximity, platform, and productivity, right? So the proximity to data, bringing your data and applications closer together, platform and productivity, of course, like I said before, you'd see how fast it is for you to get embeddings done I have a sample data set of 1,000 records, but you'll see how fast it is, how productive it is to get that done with AlloyDB's ability to work with PG vector extension, which is the vector database. So vector is nothing but a representation of, it's a numerical representation of any data, which is text, but you have text embeddings so embeddings API is one of the models or one of the APIs in Vertex AI, which we'll use to convert data or text data into vectors. Vectors is a numerical representation, right? You know that. Why do we need vectors? Because when we are doing fast searches, like not just Elastic, any kind of search, not just based on keywords, but you want to search based on meaning. For example, I might be using one word to represent machine learning or natural language, but there could be other words in that context that fall within the scope of that particular literature that I'm searching for. But am I looking for keyword search here? Do I only need results that match the exact keywords that I'm looking for? No. How many times have you encountered scenarios where you feel like, okay, why will it not understand what exactly I want, and search the underlying database or search the entire result set that it has for the exact meaning match, not necessarily just the keyword match, right? So that is exactly what we are going to do, and we are going to use embeddings for that, because embeddings convert your data into, embeddings convert your data into vectors, which is the numerical representation of it, and it is just an array of floats, if you want to imagine it, right? But AlloyDB is a database that we are going to use for storing that, and going to look at it hands-on. And in AlloyDB, it has a native way of storing vectors, which we call the PG vector extension. And we will use cosine similarity. You can use many other ways. You can use even Vertex AI's vector search in order to do this, and create indexes. But in the interest of bringing applications, generative AI applications, closer to where your data resides, what we're going to do is we are going to use cosine similarity only within the scope of AlloyDB, right? So are you ready to just use SQL query and then bring machine learning or embeddings and vector search, which is generative AI, to your data, to your searches? Yeah? Just using SQL? All right. Now, I don't know if you all have your laptops in your hand, but if you do, feel free to just scan a few things. Let me just show you that right away. 1 second. So this is the demo we are going to perform right now. And this is the GitHub repository for that, in case you want to look at it later on. So we will use AlloyDB to store the data, and we will do patent search. Basically, we want to search by literature. We'll just use some text. Let's say I want to search about automobiles, ideas in the automobile industry, or ideas about transmission, or ideas about natural language processing, a new ML model for natural language processing. I'll just put keyword and search. It will bring in patent data, which is publicly available in BigQuery. I've just imported that data into insert scripts and made available in this repository. You can just write insert scripts to run it into AlloyDB, right? And then from there, we'll run a few 2 or 3 queries. That's it. You would have gotten yourself embeddings. You would have gotten yourself cosine similarity, and we'll match what as a user you enter as a search text and what is the closest match that it brings about for you from the patent database. All right. So that is exactly what we're going to do. So this is your GitHub repository, and here is your Google Cloud credits. If you want to try this out, right now or later on, this is your Google Cloud credits. Just take a note of it. Make sure to redeem these credits from your personal account, Gmail account. Because like if you use your corporate account, sometimes you might not be able to activate those credits. So yeah, use your personal Gmail accounts, and don't try to access it from your mobile, because then it'll be difficult for you to translate it to your account where Google Cloud is logged in. All right, so let's get started. I am on my console.cloud.google.com, but before that, let me just walk you through the use case. I already said that. User wants to search for a specific text in patent literature, and the patent data is stored in AlloyDB. I want to perform a meaning-driven search, not just keyword-driven, right? The app data is stored in AlloyDB, like I established before. It uses PG vector extension for embeddings, converting the text that is there for each patent, right? The abstract of each patent text into vector representation. And I'm using cosine similarity to perform my vector search. The app is deployed as a Cloud Function endpoint. So this is your serverless runtime. How many of you have used Cloud Functions? Anybody? Okay, you've used it. So you know it's a serverless runtime. So what is serverless? Is it it's as simple as just writing your application and not just running it in your own local system, or you having to maintain your server. It doesn't mean there is no server. It's just that you don't maintain that particular server. The cloud provider, in this case Google Cloud, the runtimes Cloud Run and Cloud Function take care of everything from that point onwards. It just takes your code and it packages it, it containerizes it, it deploys it on the cloud if it's Cloud Run. If it's Cloud Function, it doesn't have to containerize. Behind the scenes it does, but it just takes your code and it publishes it as a REST endpoint. As simple as that. In just 2 minutes, we'll do that. You will see how it is. All right. So why AlloyDB? I mean, of course, you would have, some of you have already used BigQuery. BigQuery is very famous in this area where, you do everything in the scope of data. AlloyDB is also really great in performance, and it compares with both transactional and analytical use cases as well. I just wanted to talk about AlloyDB. I just like to say that, although my favorite database is BigQuery and Spanner as well. I mean, in the recent times. Now, like as of yesterday, I started liking AlloyDB as well. My goodness, it just blew my mind in performance. You'll figure that out if you're trying to run this repository on your own. It'll take a few seconds, I'm telling you, just a few seconds to translate text data to embeddings, which just blew my mind. Not one by one, like all at once. So, all right. So, of course, for its high performance, high availability, scalability, security, and compliance with all the compliance standards that are required. So, for all those reasons, and I already told you what Cloud Functions is. So, let's go ahead and create a AlloyDB cluster. So, go to console.cloud.google.com. This is where you get started. So this is where you go, console.cloud.google.com. So this is your landing page where you go to Google Cloud Console. Make sure you have if you use that try GCP link, which I showed you in a couple of slides ago, like the credits link, you will get a billing account created. It's $5 worth, $1 worth. I don't know how much it is, but it's enough to go through this exercise and more, unless you're keeping the Cloud Function or spreading it out and people are hitting it multiple times, you're good to go. And then make sure your project is selected. Now go ahead in the search bar, search for AlloyDB. If it's the first time you're using it, go ahead and click the enable API button. In my case, it's already enabled. It's the enterprise grade Postgres compatible database. So go in there. It's also, as you guessed it rightly, is Postgres compatible. So the data is very close to how you operate on relational database management system, and it is supportive of both transactional and analytical workloads. All right. So now once you're here in AlloyDB's console, go ahead and create a new cluster. All you have to provide is just the option. In this case, since you're trying it out, go for basic, click continue, and then you'll you have to provide some basic information about your cluster, nothing much. So just go for basic, continue, make sure you have a cluster ID, password, version of your choice, of course, and then version, make sure your region is US Central 1, because we want to use some of the LLM APIs that are highly available in some of the areas. You can read the documentation for which areas you want to use, or how, mostly it depends on the design for your data, like where your data is accessible and what region you can select. But I tend to usually use US Central 1, so you can follow that as well. And networking, it'll take about a few seconds for this step to complete. You have to set it to default, and go with some networking configurations as and when it asks you there. It's just nothing. You can leave all the things to default for this trial application that you're running, and then hit create cluster. Once you create your cluster, you will have the option to create your instance as well. So for the instance in AlloyDB, it'll ask for instance ID or instance name. In my case, I've given the instance name as AlloyDB-instance. And then once you create that instance, it will give you the connection URI. As you can see, it has your project ID. It has the location that you chose for your cluster and instance. It has your cluster ID. It has your instance ID. This is important because we're talking about databases, cloud databases, and runtimes, serverless runtimes. So when we talk about serverless runtimes, you have to connect it to your application. There are multiple ways to connect. One of the ways is using its connection URI. And so this part is really important for you to make a note of, unless you're using some other method to connect. In this case, we'll use the connection URI to connect. So keep a note of that. All right, now my cluster is ready, instance is ready. I'll go ahead and go to AlloyDB Studio. Click AlloyDB Studio. It comes in with, as you can see, Gemini auto code recommendation and all that. So queries in Google Cloud, even SQL queries, just like, I don't know if any of you have already tried Cloud Shell and how Gemini Code Assist helps you write code, complete code, search for questions around code, understand the context and recommend additional features, so on and so forth. So similarly, similar features are available for the database code as well. So feel free to use that if required. In this case, I have very lightweight, simple, straightforward DDLs, DMLs, and queries. So we're just going to go ahead and address what we're going to do. First thing, we have created AlloyDB. We have enabled the APIs. We have created a cluster. We have created instance. Now I clicked AlloyDB Studio, and I'm going to create run the DDL statement, which is to create data definition language, which is creating your table and populating it with records, right? So I'm going to create the table. Like I said, it's literature data, which is patent data, right? I already have the data from BigQuery database, which is publicly available. So go and explore BigQuery public data for any of your prototypes or any application that you're building and you want some instant results to see if your idea works or not. So I have used the data from there. BigQuery's public data set for patents database. So as you can see, this is my create query. I have ID of the patent. I have the type, number, country, date, abstract of the patent, title, kind of patent, number of claims, file name, supporting files, and whether it's withdrawn or not, or indicated by a number. Okay, so these are the fields I have. Go ahead and run that. It'll take a very split second. Actually, it just completes in a blink. And then once that's complete, let's go ahead and create. As you can see, the steps are listed here in the GitHub repository, which you probably scanned when I showed that QR code. So now that our DDL, the table is ready, the next step is let's create the extension. So what is the extension for? Can someone tell me? What is the extension PG vector for? Sorry? Come again? Embeddings, vector embeddings, yes. And there is another extension that we'll use. It's called Google ML integration. So we'll use these, we'll create these two extensions. Just copy this create extension vector, create extension Google ML integration, and run it from your AlloyDB Studio. Go ahead here, run these two. Again, these two are also pretty straightforward. It'll create instantly. I've already run this like a few minutes before the session, so I'm not going to run it again. And then once your extensions are created, it's actually called vector, right? So you have to create, it's PG vector, but it's referred to as vector. when you're creating the extension. Same with Google ML integration. You need this Google ML integration. Why? Because you're asking AlloyDB to talk to Vertex AI for all the APIs and models and everything. So you need to activate that extension as well, install that extension as well. And then grant execute on function embedding to Postgres. Now, embedding is a built-in function that's available for use once you have this vector extension and Google ML integration set up, right? So go ahead and grant that, run that grant execute command as well. Once that is done, what I'm going to do now is make a slight change in the table, the schema. I'm going to add a column called abstract underscore embeddings. So I'm going to convert the abstract field into embeddings because that is the field that has the most information about the patent, at least as far as this database is concerned. So I'm going to convert that into embeddings. So whatever I'm searching as a user can be matched against the data set that I have, right? Using embeddings. So I'm going to add this column, vector 768. So how do I know it's 768? You can actually run one sample and see how much is the dimension that you need. And I found out that the dimension was 768, and that's pretty default for all your text embeddings, so you can go ahead with that. So go ahead and run this, and I've already created this. Now the table has all these fields that we addressed before. In addition to that, we have abstract embeddings. Now that all this is there, where is the data, right? So if you go to the GitHub repository, the data is made available in this file called insert scripts.sql. Go ahead, copy that, bring it back to your AlloyDB Studio and run it. You'll see how insignificant amount of time it takes, like in a few seconds, not even a few seconds. It's really fast. It just completes insertion. In this case, it's about 1500 records, if I'm not wrong. It immediately runs inserts really quickly, and once it's done, now we have the table. Now we have the cluster, we have the instance, we have the table, we have the data, and we have enabled all the extensions that are necessary. Let's go ahead and test if embeddings work, right? So how am I going to test that? Let me just run this select embedding, text embedding gecko at 001. So this, have you heard of this? Has anyone used this from Vertex AI Model Garden? Text embedding gecko? No? So this is embeddings API. 001 is, now we have 003 as well. So feel free to use 003 instead. That is totally fine too. I'm going to run this. So what this means is you're calling the embedding function on this model. And for which text? This is the sample text that I'm trying it on. AlloyDB is a managed cloud-hosted SQL database service. So I'm just going to run this to see what the embeddings result looks like. Because a lot of people, for some reason, have continuously asked me to show what embeddings result converted looks like. So this is what it looks like. Copy paste, you will find that its dimensions match the dimension that we have set for this field. And that's about it. It's in my mind, is just an array of floats. So once we are ready with all this, all I have to do now is just to make sure that, remember the data set that we brought in from patents database, that does not have embeddings, abstract embeddings field populated, right? Let's go ahead and check that. Select star from patents data. Right now it may have, because I've already run the update statement, but typically when you're running it in the order that is mentioned in the GitHub repository, you will see that it contains the fields ID, type, number, country, date, so on and so forth. And the abstract, never mind, it's still empty. The abstract embeddings, as you can see right here, is empty. So go ahead and run the update abstract embeddings query. It'll take about a few seconds, but this will actually update all the records in your patent database to match the, to convert the abstract data that you have for each and every patent into vector representation. That's it. How simple was that? It was all in scope of the database, right? Let me see if my internet is flaky again. No? All right. So while this is running, let me go over to the next step in the GitHub repository, which is we have created the inserts. Okay, one thing which is missing is granting Vertex AI user role to AlloyDB service account. Why do we need that? We've already established that we need the extensions, but where are you explicitly calling out the permissions? You need to do that, right? So go to IAM, Identity and Access Management, and search for the AlloyDB's service account and provision it the access to Vertex AI user. So that's pretty straightforward. Go to console.cloud.google.com, click the hamburger menu, go to IAM and admin, and in here you can just select Once it loads, again, I'm not sure of the internet right here, but once it loads, you can probably look at principals, grant access, search for AlloyDB in your principals. It should bring up the service account that corresponds to your AlloyDB database. Select that and assign it a role of Vertex AI user. Select that and click save. In my case, I've already added it, so there is no change in my principal, with my policy on this principal. So I'm going to leave it as it is. So what is next? This is not normal. So what do I have next? We have created insert DML. We have granted the role for Vertex AI user to the AlloyDB service account. The next part is testing if the embedding function works, which we have already done. We saw what embedding looks like, so we have done that. Update SQL, it's going on. The next one is query to check if cosine similarity works or not. So I'm going to copy this. Select query. So this is all that you need. This is the actual vector search. So imagine the complicated vector search that you were brainstorming so much about, thinking so much about. Is just this 2-line query which says select star from patents data, order by abstract embeddings. What is abstract embeddings field? It's the field where we stored the embeddings vector, right? And then the double-edged arrow enclosing the equal. So that is the sign that represents its cosine similarity. If you choose a hyphen with double arrow, it probably means D2 distance, some other algorithm. In this case, we are using cosine similarity method for identifying the match. And then we are calling the embedding method on the test idea, the test literature. My test literature is a new natural language processing related machine learning model. So that's my idea. I want to see how many patents are already there in the database matching this. So why am I calling? Can someone tell me why is there an embedding function call over there? Correct. So this is the user search text, right? We need to convert that also into embedding. You can't compare a text against an embedding. You have to compare embedding against embedding, text embedding against text embedding. So that's what exactly I'm doing right here. I'm converting the text search to embeddings as well, and I'm doing a cosine similarity against all embeddings of the abstract, right, to bring up the closest match. Now let me copy that. Yeah, I don't think the internet's let me run any new query here, but I'm still going to try to give you this result. Let me see if I have something that's already open. Okay, this one's right here. All right, let's run this the same query, which you just saw. There you go. So this is the result. So I want top 10 matches of the text that I just told you, a new natural language processing related ML model. As you can see, I wanted to bring back the ID concatenated with its title. So as you can see right here, contextual language understanding for multi-language tasks. As you can see right here, it's not a one-to-one keyword match, although it understands the meaning of the search that you provide, and then it brings back the closest matches, which is pretty impressive. Like everything is related. Top 10 matches are really close. I like cosine matches. It's fun too. Sometimes cosine match, and there is, how many of you like cosine over linear? No reason? Find out why you would like one over the other. It's an interesting debate in itself. I have no time to cover that right now, but that's for another day. But if you like to change this text, please go ahead and change and find out. Now, one last thing. Where is the application? Where is the cloud runtime that we talked about, right? So now go to the GitHub repository. You see what is 10th step, which is just creating cloud functions, deploy, and test it on the web. So where are these cloud functions I'm talking about? In the repository, I have provisioned two files. One is the pom.xml. So I've built a Java application, a pom.xml that supports with the dependencies, and the main Java class that contains the code which reads from AlloyDB and presents the result to you. All right, so I'm going to copy this from here. You can actually clone it and do all that, but I'm just going to show you how you can do it from console. So go to console.cloud.google.com, search for cloud functions. If it's the first time you're accessing it, it'll ask you to enable API. Go ahead and do that. Select cloud functions. It'll show up like this. Search for cloud functions. There we go. Okay, create a function. It's as simple as a few clicks, you will get your serverless application created and deployed. So I'm just going to name it function 1 for now. I'm not going to change anything. I'm going to allow unauthenticated invocations because I don't want to I don't want to set anything right now for authentication. Runtime, like I told you, I have created a Java application, so I'm going to choose Java 11. Pom.xml, it's available here in my GitHub repository. So as you can see, the dependencies. Why is it not loading? Okay. So here is my pom.xml. I'll just go here and replace this pom.xml content from this. And then I'll go to src main Java hello HTTP function. You might have to change the class names and all that. Go here. Hello world. I mean, it's there in the repository as well, GitHub as well. You can copy from there directly. Take that, replace it, and make a few changes. Like you'll have to change your project ID. You might have to change your cluster ID. You might have to change your instance ID and click deploy. That's it. It takes a few maybe less than 2 minutes for it to deploy your cloud function. And once it's deployed, you will get an endpoint that looks like this, right? So you can, let me show you how it looks like. Right now I have input request parameter, so it won't return anything on the web console itself. So what I'm going to do is I'm going to go to testing. So let me show you how I'll test my cloud function. So it has one JSON value, search, and my search value is, let's say I want to bring back results related to automobile, right? And click test function. So I want to see if there are patents in the database related to automobile field. So let's see what happens. It's running. It's waiting for the test to finish. It'll bring one closest match. If not, I'll change if there is no data related to automobile, I'll try to bring in the same use case which we saw. We're almost there. There we go. Okay, so this is the test that I ran. So the search and the search text is a new natural language process. So I ran both at the same time. This one has brought the closest match, which is contextual language understanding for multi-turn language tasks. This is one, and the automobile thing that is still running, that's probably because we didn't change the project ID and all that when we deployed it. But that's okay. This is basically what I wanted to talk to you about, deploying applications and bringing LLMs closer to your data and deploy it in cloud runtimes serverlessly. Thank you.